Today we're going to talk about muscle contraction, and the goal of this video is to describe how muscle fibers contract. So first we need to talk about myofilaments and how they're arranged. So actin and myosin filaments work together to produce a muscle contraction, and they are attached to each other at a Z line. The space between two Z lines is called a sarcomere. The actin and myosin interact to pull the muscle fiber towards what's called the M line, and this shortens the muscle fiber. So here I've labeled the actin, and there's the Z line, and again, the space between the Z lines is called the sarcomere. Okay, now how do muscle fibers contract? Well, a nerve impulse is sent to the muscle fiber to begin contraction. And the myosin filaments have these rounded extensions called heads. And these heads attach to the twisted actin filaments and pull on them. The Z lines get closer together, and this causes the sarcomere to get shorter. This process is called the sliding filament theory. It repeats until the muscle contracts completely. And the energy required for this process comes from ATP. So here I'm going to show you 5 steps in a muscle contraction. It forms a cycle. So in step 1, you have the beginning of the contraction cycle. So ATP energizes a myosin head, and it's converted into ADP. In step 2, the active site is exposed, and there's this thing called a cross bridge formation. So basically, calcium ions bond to troponin, and this removes the blocking action of tropomyosin and exposes the active site. The myosin head attaches to the actin filament, and this creates a cross bridge. Then in step 3, the myosin head pivots. This is called the power stroke. So energy that's stored in the myosin head is used to pull the actin filaments toward the M line, and ADP is released. In step 4, this is detachment. So as a new ATP attaches to the myosin head, the cross bridge detaches. And then in step 5, the myosin resets. This is called the return stroke. So the freed myosin head splits ATP into ADP, and it releases energy. This released energy recocks the myosin head to prepare for the next stroke, and the cycle can continue. So to sum up, the myosin filament pulls on the thinner actin filament to shorten a sarcomere during the sliding filament theory of muscle contraction. ATP is required to move the myosin heads and calcium ions. ATP is required to move the myosin heads, and calcium ions expose the active site for them to attach. And this cycle continues until the muscle fiber is fully contracted.